Okay, so we said there are all these benefits from doing climate mitigation, and we have already convinced ourselves that it's basically there is no choice than to do climate mitigation right now. So then the question is how much, how fast, and to what end? Out of this comes these debates about whether there is a time limit by which time will run out and it'll be all hopes lost. Uh, there is a debate because not everybody agrees with this idea of saying we have only 10 years left to save the planet. This is dangerous according to some people, and I would tend to agree that setting deadlines can be a problem, because if, let's say, we say 2030 is the deadline, 2030 is right around the corner, it comes around and nothing visible changes. Already there are bad things happening because of climate change: air pollution, water pollution, crop losses, health issues, disparities, and so on, climate conflicts. If everything continues as is after 2030, then people might say, what was this deadline? What are we supposed to expect? So nothing big may happen. So that has to be remembered. Plus, how will the politicians use this idea that there is a 10-year deadline? Some may say we must cut everything, ration everything. Some might say, look, nothing happened. So we have to be careful about that as well. So if you just look at the number of events that have happened. This is split into geophysical events, earthquakes, tsunamis, volcanic eruptions, which are natural; meteorological events like tropical storm, winter storm, thunderstorm, which are natural but are being altered by global warming, as we talked about the increase in extreme events, droughts, floods, and so on, right? Hydrologic events like floods and mass movements or climate displacements seriously being affected by global warming. Climatological events like extreme temperatures, droughts, and forest fires. As we said, for example, there is no evidence that forest fires have increased, but in places like California, there is drought related to global warming is making the forest fires, wildfires, much worse. Okay, people are also moving closer to the woodlands because they like to live in the woods, near the woods. Also makes for a bad combination. As for extreme temperatures, for example, we talked about the example of Siberia, where if you ask the question whether the 2010 heat wave was made more probable or stronger, more extreme, then the answers could be very different. So the idea there was that the climate change loads the dice. So extreme temperatures, droughts, and forest fires are occurring in a natural climate, but their numbers may increase or their intensity may increase, and probability of them occurring may go from 1 in 100 years to 1 in 20 years, 1 in 10 years, and so on. Okay, so you can see that there is a general upward trend, especially in these hydrological and meteorological events. There is still year-to-year variability, because when you have El Nino or La Nina or other modes of natural climate variability like Pacific Decadal Oscillation, North Pacific Oscillation, there are many things that we haven't touched on. They modify global rainfall distribution, global temperatures, and so on. For example, in 2020 we have a La Nina happening in the tropical Pacific. This in general favors hurricanes in the Atlantic, and the Atlantic has broken all records this year for hurricanes. Okay, total number of hurricanes has reached the highest ever, as far as we know. Okay, so number of disasters is increasing. If you look at the other species, this is from the International Union of Conservation Network. The species assessed by the IUCN include these red list, where amphibians are facing a risk of extinction at 40%, conifers, coral reefs, sharks and rays, birds, mammals, selected crustaceans. So it's not only about us, right? The planet hosts all these life forms, they don't have much to do with all this global warming business, and we are putting their lives in danger. This is often referred to as the sixth extinction. So, is that going to motivate us to do things fast? Maybe. So if you look at cumulative CO2 and the warming, this is showing years versus increase in CO2. So this is global greenhouse gas emission in gigaton carbon, gigaton CO2 equivalent, and we are here now at 50 or so, and all projections show an increase. Okay, so the previous projections are shown here. So here are the options depending on which target you want to pick for 2050 in terms of the global warming. Okay, let's say we pick 1.5 degrees or 1.5 to 2 degrees. This comes with the probability. Let's say we decide to keep the global warming to below 2 degrees with a probability of 66%, then what do we need to do? We basically have these estimates of where CO2 emissions have to go. So if you want to go to this target here, you have to reduce your emissions down to basically for 1.5 you have to go to 0 by 2050 and so on. Okay, so we take that and we take the CO2 emissions per year that we have from the past, and we say how many years does that give us. This is because CO2 accumulates in the atmosphere. As we said, 40% of the emitted CO2 remains in the atmosphere. So given a target that we want to hit, knowing the amount of carbon dioxide we are emitting per year, carbon dioxide equivalent, you can say, okay, this will take about 10 years before we reach the total carbon we are estimating for this level of warming. This is where the deadlines come from. As I said, this is a bit controversial. Nonetheless, the impacts that go with it, extreme heat waves with severe societal impacts are already here. With warming, as the colors get red, we get major risk to most coral reefs, high risks of regional food security, tipping point of Greenland ice sheet. These are somewhat uncertain as well, but Greenland is melting, and it's melting faster and faster because there is something called an ice albedo feedback, which means ice is a reflective surface. If it melts, then the reflectivity decreases. Earth absorbs more energy, then more it gets warmer, more glacier melts, and then it accelerates very fast. And from the previous ice ages, we know that this change can happen really fast. That's where these ideas of tipping points come from. Millions risk displacement by sea level, significant Amazon feedback, dieback, global crop decline, global mass extinction, extreme precipitation, unprecedented heat waves, and adaptation highly questionable. Things will become so bad that we may not even be able to adapt to the changes in terms of, let's say, agriculture. If the rainfall becomes so extreme that crops are going to get damaged, then you may not even be able to adjust. Okay? This is another way to look at it. The carbon dioxide decrease needed in billion tons per year, gigatons carbon dioxide per year. CO2 emissions decline from 2020 to reach net zero by 2055 or 2050. So 2055 gives us more room, but 2040 requires a very sharp drop in the amount of CO2 we can afford to emit. Okay? This doesn't mean that everything will be zero carbon. We will see that some things will be emitting carbon, like agriculture, but we will need other ways of taking out carbon dioxide. We'll have low carbon emission from, let's say, power generation or transportation, but we have to have effective, scalable, affordable carbon capture, what is called ACE in this book, atmospheric carbon extraction, also referred to as CCS, or carbon capture and sequestration. So we'll have to take out more carbon than we put in. That's kind of the key challenge.